So, hi, Richard. Welcome back.
Hey, thanks, Adam. Glad to be here.
So, last time we covered Ford Mustangs and your apps, and today I would like to hear a little bit more about the algorithms and, of course, Java as much as possible, because what you told me that you're running full stack Java.
Yes. Yeah, in fact, in modern Java. So let's see. For those who may be tuning in for the first time and not hearing the first one, maybe a little brief update. So we're working at this company, Hashgraph, and we write software for the Hedera public ledger. And actually, all of our software has been donated to the Linux Foundation. Not all of the repos have been moved over yet. A lot of them have. And in fact, today we are moving over the consensus node software. Even as we speak, um, they're moving over the consensus node software. So by the time you're hearing this podcast, you'll be able to go find it. The name of the project in the Linux Foundation is called Hiero. It's kind of like the first word of hieroglyphic. So Hiero. So if you looked up Hiero-ledger on GitHub, you'll find it. And we have a lot of our SDKs that are out there right now, and sort of our main software. And what we're building, of course, the Hedera public ledger is a blockchain or distributed ledger. They're kind of both the same concept, different names for it. But basically, it's a distributed ledger is like a decentralized database. Each one of the computers or nodes that are running the software has a complete copy of all of the state. And when a transaction is submitted to any one of those nodes, they will gossip it to all the others. They will use the hashgraph algorithm to come to a fair order on which transactions there are and what order they arrived in. Then each one of those computers will individually apply those transactions to the state, get a new state, right, based on applying those transactions. Then they will get a hash of that state, gossip that hash with each other. And if more than 2/3 of them agree with the result of the execution of those transactions, then they will also have all signed it. And then you will get a blockchain as an output of this process. So we have these nodes sort of work together in a democratic fashion. If more than 2/3 of them agree, then they produce a block and the block goes out, which is sort of in contrast to Bitcoin or Ethereum or Solana or many other networks where they have a leader who produces the block. In the case of Hedera, it's democratic and the network produces the blocks. So in that, each one of those computers is running all of our code is in Java on each one of those computers.
One question, because why? So you are not very visible, your company. So this is interesting for Java developers. So because I take a look at the homepage, hedera.com, and it started with papers, so I can download the papers. It is serious. It's actually a big deal. There's Dell, IBM, everyone is there.
Yeah.
And looks nice. And everything is Java, modern Java, which is also interesting.
Yeah.
But where the DevOps talks, or
yeah,
Jax?
I know, right? So,
this is impossible, because this is actually a great example what you can do with Java, and but absolutely stealth mode, right? So
yeah. No, it's true. And part of that is just sort of being heads down and building things.
Okay.
But like this year, we're supposed to go to Java 1, which I need to register for. But supposed to go to Java 1 and to DevOps. And actually, Hendrik Ebers, who you may know, he's on our team, and he's done a number of conferences in Europe. But a lot of our conferences have been either in the sort of blockchain, crypto, Web3 space.
Oh, okay.
Or in actually Web 2, and not specifically in Java. And I always felt like that was something that we should address. So we're trying to address that this year and spend more time reaching out to the Java community. Now, to be fair, blockchain also has had a sort of negative connotation for a lot of people, and including a lot of great people who were just kind of confused by it because they see the the casino side of the thing, and
Mhm.
they don't see sort of the practical application of it, and which I don't blame them for, because it's like all you're going to get from the readily accessible news sources is going to be the casino side of the deal, because it's so salacious. Somebody gets 1 million Bitcoin and at $2, and now it's at $100,000, and so they're extremely wealthy, except they lost their key and they can't access it, and somebody's hacking it. There's all these sorts of things that make the highlights of the news. All the
And
sort of
ransomware,
boring.
right? So all the negative stuff, like you have to pay
Yeah,
bitcoins in order to decrypt your drive. Yeah, but I
yeah,
think
there's like what Web3 is going great website, where they talk about all the money people have lost on it. All that kind of stuff is what people are exposed to. So unless you're in the industry, you aren't aware of all the other things that are getting built on top of it.
exactly, because for me, the easiest way to understand what's going on is the first, if you know Git, you are already half there. So, I mean, Git
Yeah,
is also,
right.
yeah, this is interesting. And maybe a use case I had years ago, and this was like, it had to be communication between peers, but it had to be auditable, and it had to be verifiable afterwards.
Yep.
Yeah, and
Yep.
this
Yep.
is we had a chat, and I would say we have to use blockchain for that, because it is like it is. Everyone can verify, and this was highly secure software. And I say, or Git would also work, because Git is what you described. Git is also similar, because you have a list of commits, and every commit is signed, and the commit points to the other commit. So what you are
Yep.
signing is the commit with the metadata plus everything, basically. So if we have two hashes, we know that we have exactly the same commit. So it is
Yep.
kind of similar to blockchain or Kafka a little bit. So I think on Java conference it would be easy to sell, or at least explain.
Explain. Yeah.
Explain what is a good for, and then it would change dramatically, I would say, because
Right.
there are use cases out there where we can use for, and this is what Java developers usually are interested in, right? So yeah.
Yes. Yeah. The interesting part of it is that in addition to that, it's basically a public ledger. You
Hmm.
could do private ledgers, but the public ledger is a hosted instance, right?
Hmm.
And using that hosted instance, you can just submit your transactions to it, and the costs are really minimal. So, like for doing if you wanted to do what you were doing, which was submit a message and have it be sort of
Hmm.
durably persistent on the blockchain, our price for that is the a 10,000th of a dollar, or like 100th of a cent, right? It's like this tiny fraction of a penny, and so it's really cheap. It's really affordable, and it's all hosted, and you don't have to worry about any of that. The infrastructure part of it's all taken care of for you,
1 million
which is
messages.
really
How much
nice.
would it be? Small messages. 1 million.
If you want to do 1 million small messages, I don't know.
Yes.
Hold on a second. 1 million small messages times 0.00130, $100.
Okay. Hmm.
So it's pretty good for the cost, and the performance is really good, because we can do 10,000 transactions per second. So even if you were to just plow that million messages all at the same, roughly the same moment in time, it doesn't take very many seconds, and you'll get through that. Um, so it's and one of the use cases that we had running on the network was a supply chain use case, and they were doing somewhere on the order of 3 or 4 thousand transactions per second of these types of transactions, and they sustained that for like a year and a half. I mean, it was we got up somewhere on the order of 72 billion transactions or something like that they ran through the network. So
And the
it was
managed
a lot.
blockchain, the public one, you are managing the blockchain, right? The public
Yeah.
one.
Well, I
Okay.
mean, we write the software for it. It's actually managed by the Hedera Governing Council. So all those names like Dell and everybody else that you saw on that page on Hedera.com, they're the ones who actually operate those nodes.
Oh,
I
okay.
don't operate them. They do.
And who gets the money? It's like a virtual company who hosts the software.
So the way that it works is that when you operate, or when you pay the fee, some of that fee goes into the Hedera treasury, and then Hedera uses that money. Like they have very few employees. They would just use that treasury to pay for. Like they would send some of it to us to develop on the software. They send some of it to the HBAR Foundation that does like community development and token
Mm-hmm.
economics, all that kind of stuff. But a portion of the fees also goes back to the users. So there's and to the node operators. So we have a special account that we call account 800. It's the account with the number 800 on it. So it's account 800 on the network is the sort of reward uh, account, and a portion of the fees goes into there. And then anybody on the network can basically participate in security. And if they do, they get a reward out of that account.
Mm-hmm.
So we haven't talked about what the security mechanism of the network is, but basically, if people like you, me, whoever have an account on Hedera, and you have some HBAR, you can use that HBAR to what we call stake to one of the nodes. So let's say that there's 30 nodes on the network, and maybe it's like, oh, I trust the Dell node. I think the Dell node is a good node, and I want to stake my HBAR to that node. So it's essentially my way of voting that that node is a good node. And if that node is up and processing and doing its stuff, throughout the day, then I get a reward from account 800 for the fact that I staked to that node.
Mm-hmm.
So it's essentially another way of looking at it is it's democracy at two different levels. It's like a representative democracy. It's like or a representative republic. On the one hand, let's say that there was a large number of nodes. Maybe there's 100, maybe there's 1,000 of them, or whatever. How many there are? A subset of them are going to be able to do consensus. Which subset depends on which ones the people stake to. So
Mm-hmm.
all the participants in the network get to choose which ones they want to stake to. Whoever has the most stake gets to participate. Those nodes then get to vote, and the weight of their vote is based on how much people have staked to them. So if
Mm-hmm.
very few people stake to one node and a whole lot stake to another node, then maybe that other node has twice as much weight in the consensus protocol
And
as the other node.
stake, what does it technically mean? This is like, do I have to cache something with my node, or have a connection with the? What is it? What is it?
Yeah. So it's different for different blockchain networks. In ours, it's what you might refer to as a liquid stake, which means, so in some blockchain networks, the way that it works is that you actually literally lock up your HBAR or your token. So you'd say, I'm going to lock up some of this token as my sort of security that this node is going to be a good node. And if it turns out that the node is a bad node, I lose I
Uh-huh.
lose what I locked up on it.
Okay.
In Hedera, we do it differently, where we say, I can still use my HBAR all day long. It doesn't matter. But whatever my account balance is contributes to the stake weight of the node that I'm staking to. So another way of looking at it is like, let's say that I had a computer on the network, and that it's like the Dell computer, and let's say that there might be 300 million HBAR staked to that node, which just means a whole bunch of people's accounts have decided, hey, I like that node. And
Mm-hmm.
if you totaled up their account balances, it came out to be 300 million.
Mm-hmm.
And I might have another node, which is like the Google node, and maybe that one has 400 million HBAR stake to it. It just means that if you totaled up the balances of all the accounts that were staked to that node, it would total up to 400 million. In this case, it would mean that the Google node would have some more voting weight than the Dell node. And
Mm-hmm.
maybe I've got another node, which is like the standard bank node, and maybe they have 1 billion HBAR on them. They would have more voting power than the others as well.
But
So
does my stake in the node improve technically something, or is just on the commercial level or voting level?
it's a voting level. It's just the
Okay.
voting level. It's
Because
just
I
to
thought,
say,
if
this is who I
if
trust.
I would contribute, some processing power, but not this is just
No.
no.
Yeah.
But how I can decide whom to trust? I mean, the Dell node is just a name, right? So it is. Yeah. So.
Yeah, so currently with our council members, the stake is almost evenly distributed across all of them because they're all essentially trustworthy. You just find one
Or
to
why
stake
should
to.
Google care that it is, for instance, why should I have a node, with 1 million tokens or whatever?
Like why do you want? Well, the question is, if you want to operate a node and you want it to participate in the network,
Mm-hmm.
then you would like your node. Then your node has to be voted on by enough people. basically. There has to be enough stake on your node.
And how much is enough?
So we have so there's two settings on the network. There's a min stake and there's a max stake.
Okay.
Min stake is currently configured at 0. So actually any HBAR is enough for you to participate.
Okay.
But the amount that you contribute to consensus is very minimal until it gets up to a certain point, until you're sort of on par with the other people. And generally, and the reason we have max stake is so that we can avoid any one node having too much power. So it's like you can only go up to a certain level.
If I have a popular node, I can process more transactions, so I can earn more money, right?
Well, no, actually, all of them process the same number of transactions all the time. All of them are doing the same thing there. It's really more egalitarian than that. It's just like, I want to participate in the operation of this network, so I will run a node. And if I run a node, then I have more. I can participate more if more people stake to me. So I care about people staking to me just so that I can participate in the system. But it's not like it's not a big money maker. It's not like you would run a node because you might become a millionaire. It'd be more like you just want to run a node because you're interested in participating in the system, or you want to have the lowest latency access to information on what's happening on the network. That'd be another reason people might
exactly do it. So the higher your popularity, or how to call it, the lower the latency. Or
no, actually, even if you had very low popularity but you were part of consensus, then you would you'd still have just equal access to the data as anybody else. The difference is that if you had, say, a large number of nodes that want to participate, and we have a limit on how many nodes can be in consensus at any given time, then in order to get into that set, you have to be more popular.
Okay. So in one point of time, it becomes more important. In moment, this is like, it's a boot. I get it.
Right now, it's just bootstrapping. It doesn't really make a big difference. But one day it'll matter. It'll matter to people.
And why you would like to participate in consensus? What is the advantage?
There's, like I say, there's two reasons typically. One is just sort of egalitarian. There's a lot of people who operate nodes on blockchain networks just because it's kind of cool. It's kind of like, remember SETI at home? Where you could just run some process and help out in the search for extraterrestrial. It's kind of like that. It's like, ooh, I get to run a node. That's cool. I'm going to do that. And if the cost of operating the node is low enough, then there will be a lot of people who would be interested in doing that. Another reason why people will do it is because sort of the trust factor. Like if I'm a big institution or something like that, it's like I would actually like to run a node, because even though at least I know that my node is not evil. So if my node agrees with everybody else, then I have a higher level of trust that this whole system is working correctly. It's not just the trust that greater than 2/3 of the people are honest. It's like, at least I can do my own independent verification of everything. Okay. So that's another reason people like to run a node. And a third reason that people like to run a node is just so that they have earlier access to the data. Because the way that this happens is, let's say that we had these nodes and they're doing consensus and they're coming up with the order of transactions and they're applying those transactions, and then they are verifying that the state changes that they got are the same as everybody else. And then they produce a block and they send the block off to some other, we call it the block node. They send it to somewhere else, F3 or something like that. They go somewhere else. And then everybody else who's not a consensus node has to get that data by downloading that block and processing it, which adds latency. So if you wanted early access to the information, you would want to run a node. That allows you to see things just immediately as it's happening instead of later.
This makes sense. Because if you are part of the, let's say, replication group, and you call consensus group, then you get all the transactions immediately. So you are in sync. And if you are part of the 2/3, right, of the majority, so you have real-time data, basically, of the network. But if you're not part of this, then you have to download the data or get it asynchronously or whatever, which means less valuable. So this makes sense. And this also makes sense because if you are then Google or IBM or Dell, they are interested, to have stable nodes in order to participate all the time in the consensus. Okay.
Exactly.
So one thing, if I will create my own AirHacks node, why should I stake anyone? So why should I do this? So if I just have no stakes, I just run in a network. So what's the difference between having a stake? Yeah.
So there is so today currently the network is all permissioned. So if you did run an AirHacks one, you still wouldn't be able to join the network because only the council members are running it. We have this path to decentralization. Right now we're permissioned, but the next step will be what we call community nodes, where anybody can run a node, but you have to sort of be like a known entity. And then there's sort of anonymous nodes would be the full, totally open thing. And that one would allow anybody to run a node, even if we don't know who you are. You could be some a Martian or an AI. We would never know. So that's sort of like that path to decentralization. We're really focused on getting to the community node part, where somebody like AirHacks could do it, right? You basically have like a KYC, know your customer sort of step, and then we'd be like, okay, you can run a node. There would be some process there.
But why should I stake Google or this? Why should my node do this?
You mean you as an individual with an account, or if you were to run a node?
This is individual with account stakes the nodes,
yes.
not node stakes nodes. No.
Right.
Okay.
Right.
Okay. Then why I am as an individual now, Adam? So I have my AirHacks node, right? Why should I stake AirHacks node or Google node? Why?
Right, because you get a little reward for doing so. So it's just basically just some passive reward. You just stake, and a little slice of every transaction fee goes into that account 800, which then gets paid out to the people who stake.
That makes even more sense, because if you have larger nodes, they participate in consensus, and you get larger reward, right?
Yeah, if you have more HBAR, then you get a larger reward.
What is HBAR?
Oh, that's our native token. So it's like it's like the fuel for doing anything on the network. If you wanted okay, so let's go back. So the example that you had, where it's like, I'm going to submit a transaction to the network that represents some message that I wanted to record durably. You have to pay, like I said, it's like a hundredth of a cent in order for that transaction to go through. But you don't, like, how do you pay a hundredth of a cent? Do we have like your credit card number? Do we, how do you pay a hundredth of a cent? Well, you don't pay a hundredth of a cent directly. You do it indirectly. What you have to do is first go buy some HBARs on a marketplace somewhere, and then you pay in HBARs. So you'll transfer some HBARs from your account into these fee accounts at the time that the transaction happens. And that's so it's like Bitcoin is the fee payment and value system of Bitcoin. And Way or ETH is the value system and way that you pay for things on Ethereum. HBAR is the value and the way that you pay for things on Hedera. And the nice thing about that is that it sort of circumvents all of the problems related to dealing with fiat currencies. You don't have to deal with the fiat currencies. Everybody who wants to have HBAR, they'll go to Coinbase or Binance or something like this, and they'll buy some HBAR, and then they'll use that.
I'm thinking even maybe not differently, but or even so. What I have to do right now, so I'm running most of my systems in serverless clouds, right?
Yep.
And what we have to do often is to calculate costs per use case.
Yeah.
So because back then, the servers, Glassfish, Whitefly, so we bought the hardware. We never paid for the power because it was covered by someone else, and it just ran, which was not right because the price was artificial. But if you go to the cloud and you do it event driven, serverless, so it's pay as you go. It means this was my question regarding messages. So if I write to DynamoDB table, I have to pay some amount. Depending, one transaction costs me something, and this transaction is depending, is it consistent, is it not consistent read or write. And if I call Lambda, it depends, on the performance and the RAM. So this is gigabyte second. The slower it costs more. So and at the end, in our projects, it doesn't matter how expensive it is. It is only important that the margin is there, right? So if I call something and it costs me €1, but I gain €2, no one cares. Yeah. So And this is, for me, it seems like it's very similar. It's like,
Yep.
serverless cloud, and
Yep.
whatever I do, I pay a little thing. And it is similar to my world, because at the end of the month I get the invoice, right? This is not
Yep.
HBARs, but it's dollars. But in your case, I will buy it in advance, and whatever I do, I will to pay. But the thinking is the same. So if I would do something in your system, I will have spent some time and think, this is one transaction, this cost me that much, and you are designing the system. So what I did at conferences, I talk about cost-driven architectures.
Yep.
Which is pretty cool, because back then we could do whatever we liked and it didn't make any sense. But right now we do which pays off, right? So we say, okay, we could do everything. You can, have HBAR modules and 20 layers, but it has to be cheap. And this is why I'm asking that question, because for me it is interesting. Is this for me like serverless and distributed database, which is serverless, and I pay for transactions, which is for me normal, because pay as you go. This is what we do. It is better. Yeah, it really depends. If you have a lots of transactions, maybe it is cheaper to have your own private network, I guess. And otherwise, you use the managed service, and then and it pays off, right? So this is exactly the same here. If I have several thousand transactions per second in one point of time, it doesn't make any sense to go serverless. We will buy dedicated instances and we pay for the instances, right? So this is, I'm trying, to understand also the economics, but it's similar for me.
Yeah. I think it's very, very much the same concept, and it works the same way. In fact, it's one of the things that differentiates Hedera from a lot of the other blockchains, is that the other ones, you don't just pay in, let's say, ETH on Ethereum, but the price is denominated in ETH as well, meaning like I was very careful in saying that it costs you 1/100th of a cent in order to submit a thing. What we do is we say, what's the current exchange rate between HBARs and dollars?
Mm-hmm.
Whatever that exchange rate is, that's how many HBARs you'll have to pay. But you are fixed in US dollars for the price.
Stablecoin was the name, right? Was it not?
No, it's a different concept from stablecoins. But stablecoins are more like the price of the coin is always fixed in the fiat currency, whatever stablecoin you've got. So in a sense, it's kind of like that, where you could say, instead of charging you an HBAR, if we charged you in stablecoin, you'd get kind of the same effect.
Mm-hmm.
But in our case, the price of an HBAR is not fixed to $1. It fluctuates. It's all in an open market. So basically, if you were going to submit a transaction, let's say that, just for sake of clarity, let's say that one HBAR was worth 1/100th of a cent. In that case, when you submitted this transaction, you would just have to pay one HBAR in order to submit your transaction. But let's say instead that an HBAR was a cent. In that case, you would pay 1/100th of an HBAR in order to do this. So the amount, as the price of HBAR goes up, the amount of HBAR you need in order to run a transaction goes down. As the price of HBAR goes down relative to the dollar, the number of HBARs you need for a transaction goes up. So
the outcome is I always pay the same amount of dollar for one message.
Exactly.
Which is important for management, because I could never explain them, that every month I have to pay a different amount for my messages.
Precisely. Yes, precisely. Which is one of the things that to me was like so obviously right about the way that Hedera was doing it when I was investigating the company to see if I should join it. This is one of those things I was like, yeah, but the fiat price, the US dollar price of using another network might fluctuate completely from day to day. How could I possibly go to my finance department and say my customer acquisition cost is going to fluctuate based on the price of this token? It's like,
just curiosity, would it work? Why you just didn't pick, a virtual dollar or something? It's like let's use dollars. There are no dollars, but you could just use dollars, right?
Yeah, I don't know. I wasn't there at the time, but my guess is that there would be all sorts of regulatory challenges to calling something a dollar that wasn't a dollar.
Copyright. Maybe copyrighted.
Yeah. I would say you'd probably run into some problems with that.
It would be interesting to know whether I could create my own, a blockchain and use dollars as instead of Bitcoin. Whether it would be allowed.
I think that what you would do, because we've talked about this, like, could you do this? Would be to use a stable coin as fuel.
Yeah, but dollar would be not allowed, right?
Well, the stable coin would have the same value as a dollar. It
Yeah.
just isn't an actual dollar, but it's the same value as a dollar. So yeah, you can go ahead and use that.
Yeah, but it would be virtual anyway. There would be no real dollars involved. You will have to. Okay, the strange thing would be how to buy your dollars and give back. This is the problem, right? You need to exchange. Because you have to buy the dollar. This will be confusing because I'm buying dollars with dollars, and this is why.
Yes.
Yeah. Interesting.
But anyway,
but we wanted to talk about Java actually.
If
I would like to start my own AirHex node, what I get, how to download the software or what to do.
Yeah. So there's we're writing the docs for being able to run such a guy. But actually, let me back up. So the code is in Java for these consensus nodes, and we are on Java 21. I would like to get to the every 6 months so that we would always be on the tip. But we're working on our CI/CD pipelines and things like that so that we can do sufficient testing to be able to make those sorts of changes and make sure that everything is good. So at the moment, we're on the stable releases, but I'd like to be on the latest tip along the way. We have, let's see, we build on OpenJDK and on the Adoptium builds, the Temarin builds, and we we're on Java 21. We use all the latest language features, especially all the records and stuff we use quite heavily. I'm very much looking forward to Valhalla because I think that a lot of our we use ZGC as our garbage collector. These nodes, by the way, they're like 256 gig machines. We have like 200 gig heaps on them.
The ARM Intel, what is it? Is it all the same?
It's pretty much all Intel. I don't think we have any running on ARM, although we all do development on Macs, so we're doing development on M1s or M2s or 3s or 4s, depending on when you got hired at the company. You've got a different version of those, but so we're developing on ARM, but we actually deploy on Intel or AMD Linux machines. They're all Linux. We generate Docker images, and you just run the Docker image, so it's got some Linux, the Linux base to it.
Does the node run on plain Docker on Linux or Kubernetes or just Linux?
It just runs on Linux.
Cool.
You can run it in Kubernetes though. So we have a project. It's called Solo, and we called it Solo because you could do your own solo deployment of the network. And if you deploy Solo, you can actually pick the number of nodes you want in your network. And we use Solo for testing extensively, but it also would work for just kind of setting up your own. If you want to do your own hosted one, you could. And so Solo, you basically just have a Kubernetes, and you can, and it gives you command line tooling to be able to deploy all this stuff in there. It deploys not just the consensus nodes, but the historian sort of data lake component that's called a mirror node. It deploys the proxies, all the bits and pieces that are the UI tools that are available to you. All that kind of stuff gets deployed in there. So Solo is a really great way to just sort of try it out. Now, the consensus node itself is split into two parts. So we use Java modules. Okay, so another thing that's interesting is like we went all in on Java modules, and this was actually a challenge because we are also using Netty, and Netty has split packages where it's got two different jars with the same package in both. Doesn't work well with modules. And there's a few other libraries that had the same problem. Total pain in the neck. So trying to get the modules to all work was really frustrating. And so we've been working with a Gradle expert, and our Gradle build has a bunch of custom stuff in it. And all that work has also been pushed up. It's called High-Row Gradle Conventions. It's actually a useful project for anybody who's doing Java Gradle multi-module builds. It's got a bunch of conventions and plugins for Gradle to make that easier. But we're actually looking at one of the things that we're working on evaluating is replacing Netty with the new version of Helidon. The new version of Helidon uses virtual threads. It's all module based from the ground up, so a lot of the pain and suffering would go away. And what we use it for specifically is for gRPC. So our system is protobuf gRPC service endpoints. So if you want to submit a transaction to one of our nodes, it's going to be a gRPC request using protobuf. And so we also have our own compiler from protobuf specification to Java code that's called PBJ, like peanut butter and jelly, PBJ. It also stands for protobuf Java. And
was your idea the name?
Yes.
Yeah, I suspected that.
and it has the thing that was kind of special about it. Like, why did we do that? Because, I mean, the ones that are produced by Google have been around forever. Everybody's using them. So why did we do our own? It really came down to the fact that when we were doing it with we had this crazy thing. We would use the Google protobuf Java parsers, parse the protobuf into these objects, but those objects were kind of gnarly. So then we would convert from those objects to other objects, and then we'd pass those through the rest of our system. And when you're trying to be very efficient, the extra object allocation, overhead, and garbage collection cleanup is really painful. So what we said was like, okay, let's try to use modern Java and generate our model objects directly. So when we read it right off the protobuf, we get the objects we want to work with, and then we'll pass those through the rest of the system. Now, currently we're generating them as records, but we're having some problems with records because there are some sub fields that we want to lazily create, and records don't let us do lazy creation. And it's actually a performance problem that we have. So we're going to actually switch from records back to classes. But as long as we can turn them into a class that Valhalla can turn into a value object later that can actually get created on the stack and not the heap, then I think we would see a huge benefit in our system. Because right now we're just creating, tons. Every time we deserialize something out of protobuf, we're creating some object on the heap that the GC has to go clean up. If instead we were creating those on the stack, they're generally short-lived, but they do get passed around from method to method. But they're also generally small objects. So passing them through the stack is probably going to be more efficient than the heap.
It will be also nicer aligned in the memory. I think you could traverse them faster.
So I think that we'll benefit from that. But anyway, that's why we did PBJ. It was like, instead of creating these gnarly Java objects that got converted into clean Java objects that went through the system, we're like, let's just generate clean Java objects right out of the gate. So that's
and is it open source? Can I just use outside?
Yeah.
Hedera? Okay.
Yes. Yep. The project's called PBJ. You'll find it at github.com/hashgraph/PBJ.
Okay.
We're not planning on moving PBJ to the Hyro Linux Foundation project. Instead, we want to talk to the CNCF and see if we could submit PBJ to the CNCF, because gRPC itself is part of the CNCF at the Linux Foundation. So we felt like that'd be a more appropriate home for PBJ if we could get it over there.
Yeah.
But it's the other thing that we did in PBJ, which everybody does, right? It is we created a sort of zero copy byte system. And we had some APIs that kind of merged streams and byte arrays into a common API, which, Netty did something similar, Helidon's done something similar. Like, everybody ends up doing this because if you're doing high performance systems, you want to minimize all of your buffer copies, but you still want to have really clean API that prevents all sorts of bugs, and you want to favor immutability and all that kind of stuff. And so we ended up creating our own because I don't remember all the details. We always tried to use something off the shelf and it would never work. And we'd be like, all right, fine, we'll create our own. But what we did was to try to combine that streaming and buffers. There was a couple sharp edges in there. One of them being that streams are inherently long based and buffers are inherently integer based. And so if you were really going to combine those two concepts together, you end up having to use longs for places. And so then there's a lot of casting from int to long, which is really annoying, or I should say from long to int in various places. But but it mostly works really well. And the reason that mattered was because when you're looking at protobuf and you're doing a parsing of protobuf, the protobuf itself can be used in a streaming fashion, or it could be used in a buffer fashion. A lot of times you don't want to just read all the bytes into memory and then decode it. You want to start the decoding process. So it's kind of important that we had a single common API that we could work with that would sort of map over buffers and streams.
Do you know Francesco Nigro, or Franz?
I do not.
I had a podcast with him. He's one of the performance gurus in Quarkus. And uses Netty a lot. And he tries, to combine high performance Netty with indirectly REST-easy, or Quarkus reactive core. So Quarkus is like Helidon, is a similar project.
Yeah.
And he has also created a stress test system called Hyperfoil, and they are able to run million transactions per second with that.
Yeah.
So it sounds really, really similar. And what they do, they use the Linux IO system. I forgot the name. There's a very fast one.
Yeah, the IOU ring.
Yeah, exactly. IOU ring with Netty. And sounds very, very similar with Quarkus, but Helidon nonetheless is also a great system. And interestingly, it is also microprofile compatible, right? So you could actually pick, Helidon with your stuff and build even on top of that something, more higher level, because your stuff has to be lower level because it's crazy fast, has to be fast, right? And scalable.
Yep.
Mm-hmm. And how many dependencies do you have? Dependencies external is like just Netty, and then what else is like?
Far too many. One of our projects is to trim it down. So, for example, we have Log4j as a logging system, and we said, okay, is there something better that we can do? So the big concern that we have, of course, is supply chain vulnerabilities, supply chain attacks.
Exactly.
So the more dependencies I can get rid of, the better. I want to just trim it down to the minimal set. And whatever things that we have as a dependency, I want to make sure that our team is paying attention to every PR and every merge that's going into those things, so that we know exactly what's going into each one of our dependencies. Now, in the case of Helidon, actually, the reason I ended up there, we actually started, Jasper and I were building our own HTTP2 server, because you need HTTP2 for gRPC. And I don't need it for like generic stuff. I just need it for this specific case. And so it's like, okay, let's just build one. So I had the spec, and we just started building it. And actually, I was really in love with it. It was coming out really nicely. And then I went and looked at the new Helidon code, and I was like, these guys did a brilliant job. I mean, this is so clean. I understand exactly what they're doing. And I can subset Helidon down to just a few modules. And it ended up being like 300,000, 300K. Somewhere around 300K. And it gave me everything that I needed to be able to do a gRPC server. Whereas if I use Netty, it was like 1.5 meg or 3 meg or something like that. It was much larger. Because Netty also brought in Guava and a bunch of other stuff, and it was just like all these dependencies. There's a large tail dependencies. So actually, by moving to Helidon, I could eliminate all those dependencies and just have a half dozen modules from Helidon, and I'd be able to run it as only a few 100,000 lines of code. In which case, we could like conceivably keep track of what's going on in those projects and know what's going on and keep track of our supply chain, right? So in other places, like for Log4j, we actually have our own logging, and we're going to eliminate the Log4j. And the reason that works for us is because, I mean, if you sit back and just look at it, for some of our projects that are not these consensus nodes, we don't mess with writing our own stuff, right? We just use something off the shelf, because why not? But in this case, it's like very, very important that these nodes are very secure and very fast. And so in this case, it's like, okay, well, what do I actually need from a logging framework? You remember there was that hack on Log4j a couple of years ago, where it was like it was tied into LDAP for some reason. It's like, well, I don't need LDAP. Like, that whole thing is just a waste of space. So I even looked at SLF4j, because I was like, oh, SLF4j, I'll just do a custom backend for SLF4j that's super small and fast, or use one that they have and just use SLF4j as my API. But even that, when I went and looked at the SLF4j jar, it had all kinds of stuff in it that I was like, I don't need 80% of this. So
what I use? Java Lang System Logger?
Yes. So I tried that one as well, and I can't remember off the top of my head what the challenge was, but I wanted that one to be the answer. But there was something it was missing that we needed. But there was also but we wanted to do something very similar to what that logger is doing in terms of it being asynchronous. I want to be able to
Hmm.
submit my log
Yeah.
statement and have it go on some other thread and take care of it.
Hmm.
Because, actually in our profiles, we're spending a lot of time in logging, especially, and this was really surprising with Log4j. We used markers in Log4j, and just determining whether or not you should log was a very expensive operation because
Hmm.
it would be going through this big long list, checking markers and configuration values to figure out whether it should log or not. I was like, I don't need any of this. All I need is a very simple system. Somebody gives me a log statement. I stick it onto a queue. Somebody else writes that thing out. That's, there's not a whole lot that needs to go into it. So we did it in terms of a facade and a back end. And I know it sounds dumb. It's like, why would you do your own facade? It's like, in many applications, it is a dumb thing to do. But in this case, it's like you want to have really tight control over what's happening on the system.
Yeah, and
And that's what
I'm
matters.
actually also always building my own facades. For instance, the Java Lang system logger. I use it behind the scenes. Why I don't like it that much, because the method signatures are ugly. So if you take a look, you have to pass the first argument, I think is the log level, and then the message is not that nice. So I like to wrap them with Java interface, basically. So if I Java interface, call it logger.static methods, whatever, and I call, the log levels nicer. So for instance, even once I had a dollar logger, right? So this was $dollars. And if I logged, it measured the performance. He knew, the logger, how much memory I consumed, and it logged really in cent what they call what it cost in the cloud.
Yeah.
For it was very important for management, to show that that it works that way. And I think that why we needed sophisticated loggers back then is because back then what we wanted to do is to switch log levels in a running system. Yeah. But right now, all the admin consoles are gone. So if you change something on the system, at least in my case, we ship a new version and replace the old one. So as I move forward, right? So the logger can be a way simpler. So the problem with system logger is it is fine for my projects, but it's synchronous. In your case, you need something like you remember the disruptor pattern?
Yes. Oh yeah, we use the disruptor.
Oh yeah, oh, cool. So something like this is logger, and I think in your case is
exactly.
You are building a product, and in your case, I will remove as much as possible and build, something by myself, but which would be hard-coded. It serves only one purpose.
Exactly.
And no abstractions, no indirections, just write nice interfaces, hack everything in, be fast, and you are
That's
set.
right. I just want it to be as simple and fit for purpose as I can do in this case.
Yeah. So this is.
The other thing is that, like, if I were writing, and actually years and years and years ago, I was well, anyway, I participated in Log4j way back in the day. I don't know if anything I ever wrote was ever committed. It was like at the very early day of my career, but I was like on the mailing lists and sort of participating in conversations, all that kind of stuff, right? And the thing is that if you're doing something like a logging framework, you end up either creating a framework that's very narrowly focused and very few people ever use it, in which case they never use it. Nobody ever knows about it. Or you start adding features that everybody's asking for. And so if you're building a framework like that, you're going to have, some percentage of your system is going to be, and maybe even a large percent, maybe like 80% of what is total in your framework is only useful to a small percentage of individual developers. Like overall,
exactly.
They all need it, but I didn't need any of that stuff. So
formatting alone, right? So if you are alone in the project, you can hard code the format, and this is basically it. You need to know fancy formatters and all the possibilities. You say, okay, this is my format, done, right?
Done. We'll move on. Yeah, exactly. So we have our own our own logging and config and metrics. And the config and metrics are also very small and fit for purpose. But they also have, we do have an interface because we wanted to design this in such a way that if you were going to build, like let's say that somebody at Kafka said, hey, you guys have a great consensus system. Let me see how I can integrate that into my into my control plane for doing all this stuff. we wanted to make sure that they could continue to use Log4j or SLF4j or whatever else they're using. They could also continue to do
Uh-huh.
config
Hmm.
however they were doing it. So we do have like a little interface layer, and then we have our implementation. But they would be able to actually take a big chunk of our modules and just make use of them, and then plug in whatever system they wanted to
So
use for
really
logging
interesting
or
project you
config.
have. It sounds like the old Sun times. So it's like
It
we
tries to
built.
be.
Yeah, yeah. And how big is the software? I mean, is it like how many
I,
classes roughly?
it's a lot. It's a
Okay,
lot.
okay.
Yeah. It's actually a very sophisticated problem space. There's two. Um, so one of the things that makes it really interesting is this idea of it being decentralized. The idea that every single computer is going to be doing the exact same work and then comparing its results is different than what we would do anywhere else. Under normal circumstances, you would horizontally scale by adding new nodes, right?
Hmm. Hmm.
And you are distributing work across those nodes. Some nodes are doing some work, some nodes are doing another work, but it's not the case that every node is doing all of the work
Yeah,
because that wouldn't let you scale
yeah.
by going horizontal. In our case, though, that's really essential because when you scale the network horizontally, you're not scaling it from a performance perspective. In fact, the performance goes down a little bit the larger your network because you have to communicate
Yeah,
more between
sure.
all the different parties. Instead, what you're scaling is trust.
Hmm.
And that's the main thing that we're trying to do here is to create a system
And
that's
fail over a bit, right?
trustworthy.
Fail over.
There is failover, yes. But the trust part is essential because if it was just failover, I could do a replication factor of 3 or 4 or something like that and still split work across these nodes. But if I were to do that, then I only have the trust of 3 or 4 nodes, which is not sufficient. So we're really scaling the thing. We do get failover, the consequence, like really good failover is the consequence. But it's primarily we're scaling it based on this trust concept. And so consequently,
Wait a second. The
yeah,
more nodes you have, the more nodes can fail, right?
yes, the
So
more nodes
this
that
is
can
like
fail.
failover. Maybe not failover. Is availability. This was wrong.
Yes, yeah,
Availability.
that's right.
Availability.
So
Because you have more copies of the data and every works, but you need a consensus. And you said more than 2/3. So it means
right,
if you have a small network and 10 nodes die or are too slow, you have a problem. If you have a huge network, of course, you have also a problem because more nodes can fail
more
from
can't die.
can
Yeah,
die. Yeah, it is.
you
But
just need to make sure that. But if your mean time to failure is such that you're losing a third of your network
yeah,
on any given day, you have problems.
yeah, you're
there,
right.
there, there are
So,
problems there.
but this is yeah. Let's say if you had a stable nodes, then more can fail without any impact. So it's
Yeah.
more like yeah. Hmm.
Yeah, exactly. And each one of the nodes, because you cannot scale performance horizontally, you want to scale the performance vertically. So you want to squeeze out everything you can from the
Yeah.
each individual node. And the only way that you can scale horizontally is then by employing something like sharding, where you can, break up the
Hmm.
data into different shards, and then each shard has to have a sufficient number of computers so that it's trustworthy. You can't just have like 2 or 3, but you'd have to have, again, like 30 or 100 or something like that for each one of them. So that's how you end up scaling the thing horizontally. But each individual shard, you really just want to make it as efficient as possible. So it's a little different than like in our microservice world, where you're developing an application. You cared less about the vertical scale because it was like, how quick can I get to market? And if we have success, how quickly can I scale it out? And only
Right.
then did people get really concerned about, squeezing every last dime out of it. But initially, it was just like, slap it together and let's roll. But it's a completely different story here, where it's almost like the old days, where you would have these, you'd scale vertically,
Yeah.
and but then it's replicated many times, and every single node has to do the same thing. So places where you might like say for example a simple thing,
Master databases or hot standby or something like this, right?
almost,
So
yeah,
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 yeah, yeah.
almost like that. But one of the things that's really different is that, like, if you're a Java developer, you might very easily write some code where you're like, I'm going to put some things in a set, then I'm going to iterate over the set, and I'm going to do some stuff. or I'm going to put some stuff in a map, then I'm going to iterate over the keys of the map, and I'm going to do some stuff. That will kill you in a distributed system like this because iteration order is not guaranteed.
Mm-hmm.
And which means that I might process things in a different order on one computer than on the other computer and come to a different state change in the end.
Mm-hmm.
So it also employs a different level of thinking about the code where you have to make sure that everything that you do is deterministic, completely deterministic. You have to be careful with threads. You have to be careful with maps and sets and unordered collections and just every little thing that you do.
Thread sleep.
Yeah, how you keep track of time and things like that has to be done very carefully. So it's a very unique problem space, and I think that as a Java engineer, I was really compelled by those. That it's like, okay, I have to have a system that is extremely secure, a system that is extremely fast, and a system that behaves by this different principle of deterministic behavior. It's like, oh, that's a hard problem. That sounds fun.
Mm-hmm.
So,
let's say I'm an AirHacks node. And I'm joining with my Raspberry Pi. So I will be way too slow.
Yes.
So you need some kind of a ranking or base performance. Otherwise,
Yeah. So this is another reason why it's not open to the general public yet. But one of the things that we need to implement is what we would call our dynamic throttles. So right now we have static throttles. Basically, what we do is we have a piece of hardware, we test it, and then we added some safety factor and we set that as our limit, 10K TPS or whatever. But what we really want is to have a dynamic throttle system where actually you could plug your Raspberry Pi into the system and it wouldn't cause any. So if enough people plugged in Raspberry Pis, the overall network performance would go down.
Exactly.
But then if enough people plugged in more powerful computers, performance would go up and it would just sort of dynamically find this right level.
Okay, got you. But but this is harder, right? Because my Raspberry Pi
it's harder. Yeah.
would there would be a lag.
Yes. Now, if you were to plug your Raspberry Pi in with our given throttles, but pretty much the rest of the network, greater than 2/3 of the network was running proper machines, then your Raspberry, let's say that the load on the network is very low, your Raspberry Pi is probably fine. Everything's good. But as the load goes up, your Raspberry Pi will fall behind.
Yeah.
And then it will drop off the network because it just can't proceed any farther. And then it will, what we call, reconnect with the network. It'll do a synchronization of state with some of the other nodes on the network.
Okay.
And then it'll be able to pick up and start operating it. So if we were if you were at 5 TPS, 100 TPS, Raspberry Pi is happy. It goes up to 5,000 TPS, Raspberry Pi falls off. And then it goes back down to 100, 200, Raspberry Pi reconnects and then picks up again. That's the way that the system would work today.
For me, the Raspberry Pi node, if I fall behind, I get the old transaction data, but it actually doesn't matter, right? So I cannot. I will see old data, which I know, but at one point of time, if I keep up, then I can participate again, right? So it means, it's actually we need just a little bit of buffering or queuing, and it could work.
Yeah. So exactly, and that's how it works. So every node in the network has a few minutes worth of gossip that they buffer up. So if a node disappears and comes back online, it can ask everybody for the things that it was missing, and it can get those things. And if a node goes offline for a long period of time and then comes back online, it looks and sees where everybody else is in the process and goes, "Whoa, I'm way far old." And then it asks somebody to help it out. And that person will, that node will then, they'll basically, both of them have a tree, and they can do a tree diff algorithm and send the missing pieces over. And then the guy who comes back online applies all those changes. And now, as long as he's within a few minutes of, as long as he can complete that whole thing in a few minutes, then he's happy. If he can't complete it in a few minutes, it took a long time because he was really far behind, then he does the process again. And that process is a little faster because he's not as far behind as he was before. And then he could do it again because he's a lot closer to the tip. And eventually he'll get close enough to the tip that he's able to just start gossiping and catch up from there. So that's essentially that.
I fear I have to re-invite you back because what I would like to know,
I
would like to talk about is to write such a transaction in Java, really. So it's just hello world or just my message, I just chaining messages. So let's say, someone calls you and you would like to have the entire conversation and signed in your blockchain, and how to do that with Java. And yeah, really interesting project. And you will see Java 1, maybe. So I will attend
I hope
that
so.
talk.
I'm supposed to. We'll see.
So where people can find you in the internet?
Me personally?
You and Hedera and
yeah. I would go to github.com/Hiero Ledger, HIERO LEDGER. That's where all the stuff is going. We have weekly technical steering committee meetings that are open to the public that anybody can join. We have a Discord channel that honestly is not used as much as it should be. So I would say that those TSC meetings are probably the best, or just getting into any one of those projects and opening issues. We have a particular repo that's called the HIP or well, it's currently called the Hedera Improvement Proposals. It's going to change to the Hiero Improvement Proposal project that people can participate in the specification of, or observe the new specifications as they're being designed. So it's like the JEPs. So people can kind of keep track there. And we also have, through the Linux Foundation, a number of we have hackathons and workshops and things like that people can also participate in.
Super cool. Thank you a lot.
Cool. All right. Sounds good. Thank you. See ya.
Bye.
Bye.